Okay, so this is how we're going to do the bootstrapping. We start out with the deterministic least squares, which you've already done. So for each value of x in the sample, we will generate a bootstrap sample of y using the above estimates. Like, we have the b sub 0 and b sub 1. So b sub 0 plus b sub 1 times x. So that gives us kind of that forecast that we did. And then we add to that the normal random variable, because the actual value of y is supposed to be centered around here and then have a random component, right? So that mean plus a random component. So this mean we have estimated as the b sub 0, b sub 0 plus b sub 1 times x, and then we generate a, since we assume normal distribution, we will generate a normal random variable, okay, with a mean of 0 and the standard error that we have computed as std s sub yx. Okay. So that's going to give us a sample value for y for each given x, and then for that y and x, the bootstrapped sample of y and x, and we will um, set up an intercept, slope, and stdx uh, functions, and use that to come up with forecast. So you're going to boost, and then of course we're going to simulate 10,000 times, so which means this normal random variable will be simulated 10,000 times. So we get 10,000 samples, just one sample. Okay, so instead of just one sample, we'll set up a bootstrap sample one time, but then we'll repeat that in the simulation process 10,000 times. It's still not um, that robust as if you actually have 10,000 real values, but still in the absence of a large sample, with the given small sample, we'll be able to bootstrap as many samples as we like. So here the first thing to do is to set up a bootstrap sample, so which will be like intercept, okay, f4 plus slope, make that f4 as well, times the x value. Okay, so this will be our uh, estimated y hat. Okay, so y hat value, and then we're going to add to that risk normal. Okay, 0, because the mean is 0, and then the standard error is standard deviation is that one, and make that f4 as well. So this will be bootstrap sample for x equal to 1, right? All right. Now copy that down here. So we have a bootstrap sample, one bootstrap sample for each x value. Okay. Now based on this bootstrap value sample, okay, we can set up the intercept. Okay, y value, comma, the x values. X values are the predictors, right? Okay, and then we have slope, again the bootstrap y and the corresponding x's, and then we have uh, standard error of y given x, and a bootstrap sample and x. Okay. Okay, now these three are going to be our output. So we'll define output there. Okay. And then we want forecast. Okay. So that's the forecast. Now except we need to change this to C24, C25 and C28. So that's good. That's the forecast. Okay. Now we want to add the risk normal to it. Okay, so that will be add to risk normal 0 comma the standard error of estimate that we have simulated. Okay, so this will give us a more robust forecast. Okay, so we want that to be in output as well. Okay, so we have set up the parameters. Okay, the Bootstrap sample and the estimates based on the Bootstrap samples, and then the forecast based on those estimates. Okay, so now let's go to settings and make sure, so 10,000, we want that to be automatic, and we will set fixed seed of 1. Okay, so now we are ready to run the simulation. Okay, so we have the Bootstrap sample and then the estimates. Now we need so if we look at the results, and you see that there is a wide range. We get from the deterministic model, we get just one forecast, whereas in the simulated model with Bootstrap sample, we have a range of forecasts, and the forecast here is anywhere between 9.82 and 17.15 with a probability of 90%, and you have the percentiles here and all the rest of it. And we can now come up with Bootstrap forecast, okay, based on the Bootstrap estimates and the added normal distribution. So we have Bootstrap samples are these, and the Bootstrap regression is intercept plus slope times the x value, which is that, right? That is Bootstrap regression. Okay. Now the standard forecast, which we already have, is that, but the bootstrap forecast, okay, we can take that and add to it. We take the bootstrap regression and add risk normal 0 comma that standard error. Press F4. That will be our bootstrap forecast. Okay. And there is a difference, but it is not significant. So if you go out to some more decimal places, then you'll have. So this here is the same as that. So we can just do that, and we can add these lines into this to see how the forecasts differ. Which the forecasts are almost so close, you're probably not going to see a whole lot of difference. So let's change this original data as to just points, and then we'll add this additional layers. Add, okay, standard forecast. X values are the same as, okay, so that's our standard forecast. Okay, and we'll add bootstrap forecast, same X values, and Y values are these. Okay, all right, so now let's see, we change this chart type to that. Well, we need to series to scatter with a straight line. No, we don't want. We want only scatter points like that. And okay. All right. So you see that the bootstrap sample and bootstrap forecast and standard forecast are almost identical. It doesn't seem to have a whole lot of difference.